Okay, this will be a quick normal model review. There are basically two functions that we've learned so far for a normal model. The first one is that when we are given a z-score and we're trying to find the percentage or the area. So on our normal model picture here, we would be given a z-score of -1, let's say, so this would be a mean of 0. And remember that our standard deviation is always 1. So let's say we had a z-score of -1. We're trying to find the percentage or the area, so I'm going to find that area below. To do that on our calculator, we would press second vars and go down to normal CDF. Normal CDF is always used when we are trying to find a percentage. And in the opposite way, if we are given the percentage or given the area, and we are trying to find the z-score, so my picture might look like this. They tell us that this area right here is 25%. Okay, our job is to try and find the z-score, so we'd be looking for this z-score right here. In this case, we would go to second vars and then inverse norm. So we'll go through a couple examples here. The scenario says that IQ scores are normally distributed with a mean of 100 and a standard deviation of 16. We want to find the probability of having an IQ score below 85. Remember that with all of these normal models, we always want to start with a picture. You get credit for having a picture, so you need to make sure we do that. It looks like the mean we're working with is 100, and there is a standard deviation of 16. We're looking for below 85. So I'm going to put 85 over here. I'm trying to find this area. So first thing I would need to do is make sure I'm in z-scores. I am not currently in a z-score, so I would need to convert this 85 into a z-score. Remember, your z-score formula tells you to take your individual, subtract the average, and divide by the standard deviation. So my individual value here would be the 85. I'm subtracting the 100 and dividing by 16. This gives me a z-score of -0.94. Remember, z-scores, we typically round to 2 after the decimal. Once I have that z-score, I can now use my calculator. If I am going to be finding the area or the percentage, I'm going to be using my normal CDF. I like to write it down. So I'm hitting second vars. Normal CDF is the second one down there. Remember, it's now going to ask me for that lower and upper bound that comes from your shaded area. The lower bound was way over here on the left-hand side. That was just a very negative number. My shading area stops at 85, which was a z-score of -0.94. Mean and standard deviation stayed the same. This gives me an area or a percentage of 0.1736. You could write this as a percent if you wanted. So roughly 17% of people have an IQ score below 85. Part B says, what's the probability of having an IQ score between 85 and 125? So this problem is very similar, but now I'm looking for between. So my average is still at 100, standard deviation of 16. Now I'm looking between 85 and 125. So my shaded area would be between those two values. I do need z-scores again. We already found the z-score for 85 to be negative 0.94. So I'm going to find the z-score for this 125. So I would take my individual, which is the 125, subtract the 100, divide by standard deviation. We get 1.56. Again, I am looking for a probability or a percentage, so I will be using normal CDF again. Okay, my lower bound where my shaded area starts was at 85, which was a z-score of negative 0.94. The shaded area stopped at 125, which we just found to be a z-score of 1.56. Oops. Mean and standard deviation are staying the same. And I get 0.7670, so about 76.7% of IQ scores are between 85 and 125. Part C says Jackson has an IQ of 130. What is his percentile rank? So what percent of IQ scores are below 130? Still working with an average of 100, standard deviation of 16. Jackson's over here at 130. I'm trying to find the percent of IQ scores that are below that. So again, we're going to change this 130 into a z-score. Get 1.88 after we round. Still using normal CDF here. My lower bound starts on the left. That would be a very negative number. Upper bound stopping at that 130, which is a z-score of 1.88. Mean and standard deviation staying the same. So second bars, typing in that lower bound and upper bound. .9699, which is a percentage, would be 96.99. So this leads me to believe that Jackson has a very high IQ score. His IQ score is better than around 97% of people. Part D says, what is the minimum IQ score needed to be in the top 90%? So this time they are not giving me an IQ score. They're asking me to find the IQ score, but they're asking me if I want to be in the top 90. So top 90% would mean that I'm looking over here. This is 90%. Okay, the first thing I'm going to do in this one is use my calculator to find out what z-score cuts off that top 90%. So I am going to be switching things up and using inverse norm. So in my calculator, I'm going to second bars. This time I'm going to inverse norm. Now if you have an older calculator like mine, this calculator can only calculate areas to the left. So if I type in 0.9 right there, 0.90 for 90%, it's going to start on the left and go up to 90%. That's not what I want. I want to find that upper 90%, so I need to type in this lower area, which really would be 10%. If you have a newer calculator that allows you to pick left, right, or center, you can type in 0.9 right here and click on right hand side. Mean and standard deviation are again staying the same. So this gives me a z-score of negative 1.28. Now, it was asking for the minimum IQ score. Right now we only have a z-score, so we want to convert this z-score back into an IQ score. So using that z-score formula, that z equals x minus x bar over s, we know that z is negative 1.28. The mean and standard deviation are still going to be 116. The only thing we don't know is now that individual, that x value. From here, I'm going to solve for x. So I'm multiplying by the 16 to bring it over. And then I would add the 100, giving me 79.52. So if I wanted to be in the top 90% of IQ scores, I would need to have a minimum IQ score of 79.52. Okay, the last one here says what IQ score represents the middle 85% of the data. So when I draw my picture this time, I'm now looking for the middle 85. Okay, again, we are going to be using inverse norm because they give me a percentage. I'm going to go to my calculator, second bar, going down to inverse. Again, remember my older calculator only goes on the left, so if I type in 0.85, it's going to start right here and go to 85%. It's not quite what I want. So I need to figure out how much is left on each of these tails. Okay, I know that this thing has to add up to 100, so I'm going to take 100 and subtract the 85% that's in the middle. Gives me 15. I'm going to divide that by 2 for each tail. That leaves me with 7.5% on each tail there. So when I go to my inverse norm, I'm going to type in the 7.5% that's on the left. So 0.075. Which gives me a z-score of negative 1.44. So this is z-score right over here. And this z-score on the right-hand side should be the same thing, only positive. Again, if you have a little bit of a nicer calculator, you can just type in the 0.85 and go to center, and it should give you those two z-scores right away. Okay, from here we're finding which IQ scores represent the middle 85, so I need to convert both of these z-scores into IQ scores. So I'm going to start with the negative 1.44, again keeping that mean and standard deviation. I'm going to do the same thing for the positive 1.44. I'm going to do some work in our calculator here to find those IQ scores. So for the lower one, I got 76.96. And let's do that upper. 123.04. So those are the two IQ scores that would cut off the middle 85% of our data.